my name is Nathan Good. I'm one of the mechanical designers here at ASEI Engineering. Today we are going over water calculations. Every project where there is plumbing involved will require a water calculation. Each project will have small variations from one to the next, but today we're going to go over just the basic steps that will be a good place for you to get started on. The first step is labeling your plumbing fixtures. You do this by opening your plumbing floor plan sheet, which is whichever sheet you will be showing your water piping on. In this case, it's the P1.2 sheet. I've already labeled some of the fixtures here just to speed things along a little bit. I've labeled the lavatories Lav, the drinking fountain DF, urinals UR, and we are going to do the same now with the water closets. So do that by copying the text over and editing it to show WC for water closet. We'll do the same, the water closet next to it. And in this case, where we have two different types of fixtures that are both water closets, we are going to label this one HWC. The reason is this is in an ADA stall and a handicap stall, so we're going to label this HWC for handicap water closet. You would do something similar for any lavatories that would be wall mounted versus counter mounted. You would label them Lav 1 or Lav 2, just so that way you can keep them straight. Other fixtures we have is our mop sink here. We are going to now label the break room sink SK. And lastly, we have a couple of hose bibs. It's important to get the hose bib locations from the architect at the beginning of each project. They should be able to tell you exactly where and how many hose bibs we have. I've already done this ahead of time, and I've got one here and one hose bib located down here. Again, that was directed by the architect. The next step is opening your water calculation. You'll go to your P2.1 sheet or whatever sheet you are doing your water calculation on. Bring in the water calculation through the plumbing pull-down menu right here. So you go to plumbing, calculations, water calculation. You'll see several different options here, and we need to delete the ones that do not apply to our project. So we'll go ahead and burst to this block and then zoom in to see which ones they are. So we have our waste calculation, which we do not need. Delete that. Our water calculation that shows the booster pump. We do not need that since we do not have a booster pump on this project. And then this is our residential calc. We do not need this. In addition, here are some good notes. If you are ever not sure, you can read these notes here. These were provided by the ASEI management team just to help get you started. But we'll delete them for now. So your first step is to input all of your different fixtures that you just labeled on the previous sheet. So in this case, we will go back to our floor plan. We notice we have 4 lavatories. Come back, 4 lavs. We have 2 water closets, 2 WC here. Next, we have 2 handicap water closets, so we'll edit this to show 2 HWC. We have 2 urinals. We have 1 drinking fountain. And if you need more space, you can take this line and move it down. Copy some of these down to give yourself some more space to work with. We have 1 mop sink. We have 1 break room sink. And 2 hose bibs. It's important when you're labeling these to make sure you match whatever you labeled on the previous sheet. That way you'll have consistency within your drawings and it'll be easy to reference for the plans reviewer or contractor or anyone else who are looking at your project. The next step is to assign the fixture units based on the fixture unit type. This is provided by the IPC or the UPC. At the beginning of every project, check the local jurisdiction to see if this project is being done under the International Plumbing Code or the Universal Plumbing Code. In this case, it's done under the IPC. So I will go into my charts, go to the IPC table of fixture units, open this up, and then you'll start inputting your fixture units based on the fixture unit type that you have. So it's important to look between public and private. For any residential project, you will use the private fixture unit type. For any commercial project, you use the public fixture unit values. So we'll go back to our water calc. You see 4 lavatories. You'll find lavatory, public, because this is commercial, you'll show 2 total fixture units here. We already have that put in. 4 times 2 equals 8. Next, you'll go to your water closets. When you're doing water closets, you will notice there are 2 different options here. You'll have your flush tank and your flush valve. Make sure you get this information from the architect ahead of time to know which one you're using. In this case, I already looked at the architect ahead of time and they gave me the flush valves for this project. Also, one thing to be worried about or to notice is that sometimes the block in the background will show a tank here, and that might not always be accurate. So always double check with the architect ahead of time to make sure it's either flush tank or flush valve. As I mentioned, this is a flush valve. So we'll go to water closets, public, flush valve, 10 fixture units. So go back, we'll input 10. Since we have 2 of them, that gives you 20. Urinals, excuse me, same for the handicap water closets and regular water closets. 10, since we have 2 of them, we go to 20 for your total. Next, you look at your urinals. Urinal, public 3/4 inch valve, always use the 3/4 inch valve for urinals, and we have 5 fixture units here. So we have 5 for a total of 10. Next, you go to your drinking fountain. Drinking fountain for offices, 0.25. Next is your mop sink, which according to the IPC is the same as the service sink for offices, and you have a total of 3 fixture units. Next is your break room sink, which we use the same as the service sink in this case. And lastly, your hose bibs. Now the IPC doesn't necessarily show it in their table, so based on our experience and knowledge, we use 2.5 fixture units for all hose bibs when it's done by the IPC. Okay, and the last step here is we need to get our total GPM. So we add up our total fixture units, which in this case, I'll use a calculator. So we have 8 plus 20 plus 20 plus 10 plus 0.25 plus 3, 3, 5 to get our total of 69.25 fixture units. Let's clean this up just a little bit. And in order to convert fixture units to gallons per minute, or GPM, we have another chart that we use. So we go fixture units to GPM chart. And now again, they have 2 different columns here, one for flush tank, one for flush valve. Since we're using flush valve, we need to find our 69.25, our closest one, we have 69 here. That gives you a flow rate of 58 GPM. So we go back to our water calculation and input 58 GPM here. The next step is determining the water meter size. So we'll go back into our water calculation and go to the next step here. If you'll notice when you filled this out, this showed AA before I edited this text. There's also an AA here. Throughout the water calculation, we have certain letter designations to help guide you through the calculation. So since I put 58 here, we're going to edit this to show 58 GPM. The next step is to open up your friction loss chart that is provided to you. So we go to our water meter friction loss chart and zoom in here. And you'll need to find your gallons per minute here at the bottom, your flow rate at 58 GPM. So if we come up we have different options. We have a 2-inch meter, a 1.5-inch meter, or a 1-inch meter. But what you want to select is the smallest possible meter size that does not exceed 10 pounds of friction loss. So in this case, we have a 1-inch meter, but that would be too high. That'd be at about 17 or 18 pounds of loss. Next, we have an 1.5 inches, and if you come over here, that's at about 7.5 or 8 pound loss, or 2-inch, which would give you about 2.5 pound loss. So again, we want to use the smallest one that does not exceed 10, which gives us our 1.5-inch meter at an 8 pound friction loss. So we'll go back into our water calculation and put 1.5-inch meter at 58 GPM, gives us, as we just said, 8 PSI drop. The next step is to determine your maximum distance from the street main over to your furthest fixture away. You'll do this by finding the civil plan or the site plan that shows our building relative to where the street is. In this case, it was already provided to us. So when you're doing this, you find your main water over here in the street. So we have our 12-inch main, and our water is tapped off of this. So using the distance command, I'll type in DIST and determine our distance. So in this case, we have 38 feet for that first section, 44 feet for our second section, and so on. So I've already done this ahead of time to help save some time, and determined that we have about 350 feet from the street main to the building. We will then do the same from the building to our furthest fixture. In this case, it's where our water enters from right here over to our furthest hose bib. So I'll use the same command, DIST, to determine our distance. We have 118 feet and then another 20 feet or so. So again, I've already done this, and to determine that we have a total distance of about 160 feet here within the building. It's always important to make sure you include your vertical distance. That's the distance from underground all the way up into the roof structure, because water piping is always run tight to the roof structure, and then back down the wall. So you need to add up that total distance. From here, we're going to enter our total distance. Again, I've already done this ahead of time to figure out that we had about 520 feet of distance. Again, we had CC here. We'll input this again. 520. Go back to our calculator. 520 times 1.25, which gives us 650. This equivalent length is done to account for your different fittings within the building. So every time the water, takes a 90-degree bend or gets to a fixture or any of these other fittings within the building, that is this 1.25. You can use a smaller number if you have a very long straight run from the main over to the building, or very straight runs within the building. But for the most part, you want to stick with this 1.25 for your multiplier to get your equivalent distance. The next step is determining your system pressure drop. You go back into your water calculation to the next step below the equivalent length, which we just completed. Your main pressure is shown here as 60 psi. This is an assumption that we use based on a very typical street main pressure that you see very often. If you ever have a high-rise building which is more than 2 stories, or a long run from the street main to your building, which would be more than 1,000 feet or so, you'll want to get a flow test from the architect. This would give you a more exact number than the 60 psi, but since in this case we only have a single-story building and we have a relatively short run from the street main to the building, we are going to stick with 60 psi. You'll go to your fixture minimum here, which is given as 15 psi, which is a typical minimum required from plumbing fixtures that are flush tank or lavatories or sinks or anything else. In the case where you have flush valves, you want to switch this over to 20 psi, since that is the minimum pressure required for a flush valve water closet or urinal. The next item here is your elevation. So we show about 10 feet, which is the elevation from the water from below grade or the street main up to your highest plumbing fixture. In this case, we only have about 10 feet from below ground to your hose bibs and water closets, which are about 5 feet above ground. And then just this is a given value here, this 0.434, that is your pressure loss from gravity. You can't help gravity. Multiply that together, 10 by 4.3 to get your 4.3 pressure drop. And you go to your meter drop, which is given, which we figured out earlier in the process at 8 psi. Edit this to show 8.0. Again, before I edited this showed BB. Here it showed BB. Gives you a good job of guiding you throughout this process. This RPBP stands for your Reduced Pressure Backflow Preventer. Every commercial project has one, and a pretty standard value here you use is 10 psi. So leave that alone. The next, you need to add these total up to get your system drop. So go back to my calculator. I have 20 plus 4.3 plus 20 plus 4.3 plus 8 plus 10 gives you 42.3. Edit this to show 42.3. And that is your system pressure drop. The final step is determining your water pipe sizing chart. So we'll go back into our water calculation, and this is done by filling out the remainder of the calculation with values that we have already determined. So our main pressure of 60 psi, which was given up here, minus our system pressure drop, which we determined here, an EE. So we'll input that 42.3. So 60 minus 42.3 gives us our total available pressure of 17.7 psi. So edit that FF text to 17.7. Our next line, FF, we have our available pressure of 17.7. Divided by DD, which was our total equivalent length we determined up here in this portion, which was 650 feet. 17.7 divided by 650, back to our calculator, divided by 650, then as shown in our calculation, times 100, to get our pressure loss of 2.7 psi per 100 feet for friction loss. So we'll put that in 2.7 psi per 100 feet. The next step is to round this number down to the nearest whole number and put that in on the next line. So our water piping sized conservatively at 2.0 psi per 100 feet. If you ever have a value less than 2, it's important to talk to your engineer or a senior designer to see what we can do differently. You may need a booster pump or adjust the water calculation, because we do not want to ever have a value less than 2 in that portion. If you ever have anything higher than 8, always round down to 8, as that is the largest number that we have available in our chart. Even if it's 12 or 13, always just round down to 8. So in this case, we have 2.0 psi per 100 feet. So down lower on the water calculation, we highlight this text and bring it up to our water pipe sizing chart. If you had 3.0 or 4.0, you'd use the appropriate tables down here. Lastly, we edit these notes off to the side. We have one for the UPC and one for the IPC. Since this project is done under the IPC, we can delete the UPC note, delete this little IPC, move this up to where the previous UPC was, just so it looks a little bit cleaner. Highlight this text. It is already shown in def points, so we want to change the layer to a notes layer. Change our color to by layer, so that way it'll show up appropriately when you print it off. So as I said, this is done in the 2012 IPC. We want to match this value shown to we've already determined our water piping conservatively sized at. Edit that to 2.0. This pipe sizing chart is what you will use to determine the water pipe sizing throughout the rest of the project, but that will be done under a different training video, hopefully by someone a little bit more interesting than me. The water calculation provided in the plumbing pull-down menu does a good job of guiding you through the steps. I recommend printing off all of the charts needed, so that way you'll have easy access to them when you're running through the calculation. These charts, as well as an outline of the presentation, will be saved down along with this video. There are several items that you need from the architect in order to complete the calculation accurately. Always ask these in the kickoff meeting or at the beginning of the project so you have this information ahead of time. If you ever have any additional questions or need any help filling out the calculation, feel free to ask one of the senior designers or your engineer for any help you might need.